welcome to Beyond the Qubit. Today we have Enrique Solano from Kipu Quantum, and Kipu is really exciting company to follow because Kipu is developing software algorithms that enables the current hardware with errors and noise to solve useful problems for quantum computing. What do you want to achieve the coming 5 years?
I would like that Kipu Quantum consolidates as the world-leading historic achiever of making commercial quantum computers of today and the next generation always at the level of production in the validation of the customers, and to create an unstoppable dialogue between the hardware and our software for solving problems and to make quantum computers useful for the society and for the industry. I am totally fed up of hyping and lying to the community. I am totally tired of overpromising. And I mean, Kipu is here to show what can be done today, and that what we can do today is meaningful, valuable, and scalable.
And does Kipu become more valuable as hardware improves? Or
Absolutely.
is there a risk that today's highly optimized algorithms become obsolete at some point?
Everything, that's my point, right? So a very good point, So everything that Kipu does in relation to the commercial hardware of today and the next chip is condemned to become obsolete in 1 or 2 years. Everything, that's a fact. It's like if I tell you,
reuse it.
Sure. Everything is, let's say, every algorithmics that we develop is adapted to the next generation, So we are not dying, but then let's say, so you say it in a way, the correct way, grammatically, and in good English, correct. In the logic is correct, but somehow it reads like a tragedy. Kipu succeeds today, but because we succeed today, we may fail in the next chip generation.
Can you explain why in the next generation you will also succeed, or why are you better positioned?
Exactly.
Than the competition, that if you know the customer's roadmap, and you already have the legacy, so you know already how it works, and maybe the talent. So, and what else? What else is missing?
No, that's a good point. So allow me to be again provocative here. It is because every chip that is available today, every quantum computer available today commercially, is outdated in 1 year, that automatically disqualifies many of the things that are developed in these 12 months, right? Like solutions encoded there. So, and because the chip improves and improves and improves, changes. Just to give you an idea, the most advanced quantum computer of IBM has heavy hexagonal architecture. It is a 1,3D architecture. I mean, I know you will say, explain it. It's very hard to explain. What is a dimension 1D? What dimension 2D? What is 1.3D? It's just because they just put the qubits the way they can. They cannot do better. Now, Nighthawk is 2D, is more compact, But you know what? It is 15 times lower because of the 2D architecture. So the fact that our algorithm from the heavy hex changes and has to change the IP and everything to the 2D can be described in 2 ways. The negative one. Kipu develops, makes a world record and makes something useful with 1 chip, and in 1 or 2 years, this is not valid because the new chip changed. That's one thing. The other thing is only companies that every 12 months make their IP useless are the companies that are making it for the present and the future. You see, so the only possibility to make a successful scale-up quantum computing solutions like Kipu, recall the Liverpool message, right? You will never walk alone. The hardware will never walk alone. Every hardware, we will be by side with our shows saying, this is the way, this is the way, this is the way, this is the way. The other option is to say, in 20 years, there will be 1,000 logical qubits. I will build the algorithms for that. Sorry, but that's wishful thinking.
And Enrique, there's since I started the podcast, I
Mm.
think 1.5 years ago, is that I see 3 improvements. So first, more physical qubits per chip or per unit, and then so that's scale up, and then you have scale out. So what is the amount of clusters you can form with that unit? And then the physical to logical error correction ratio. And especially, we haven't seen really a lot of progress on forming of clusters. And that might come the coming 5 years. And also the progress on the error correction ratio. You mentioned it already a little bit.
Yeah.
What does that do? The forming of clusters. And for neutral atoms, they don't have to very fast have to move to clusters.
Yeah.
But for other modalities, they have to. And if they move to that, what does it do to your algorithms and your product? And how do you prepare for that?
Wonderful. So I will use your language because this is not very universal, the way we call it, So
maybe if I compare it, is where I borrowed it from is for AI. They talk about scale up, connecting more GPUs, and then you make a virtual GPU.
Absolutely.
So you increase the amount of qubits per unit, and then you connect them, multiple racks.
Absolutely.
And then you have the logical, the physical,
your vision got it exactly where quantum computing is doing. So we are reaching what can be called the saturation of the maximal control and fidelity possible in, let us call it, mono chips. So single units. When I tell you that the Nighthawk of IBM, that is the most advanced chip IBM produced, has 2D architecture and 120 qubits, internally, the correct sentence is, there is nothing beyond 120 and 2D architecture that could be built today or next year with the technology we know, with the engineering we know. And then when people say, but you need more qubits, right? Yes. You know that IBM produced a chip called Condor, by the way, with 1,121 qubits 2-3 years ago. This Condor was in the roadmap of IBM. They built it. It was never accessible to any customer. Why? Because it didn't work. Then before they did one with, I think, 433 qubits. It was called Oyster. That chip was never accessible to anyone because it didn't work. So they stopped in the 133, 156, 120. Now, what is the next step, as you said? What people call the modularity. So they will pick the maximal, monolayer chip, and now they start to connect it in, as you call it, clusters, right? The modular. I call it modular.
Chiplets.
Right? When you do that, then you will really start scaling. You know what? IBM offered that. It was called Flamingo architecture. They were going to put between 3 to 7 chips of the heavy hex category. You know what? This chip was never out. And the last info we got is that they discontinued the idea because it does not work. You see, now they are going to try modularity with the Nighthawks, with the 120. So you see how the most advanced hardware providers are struggling to connect 2 chips.
It's a really hard problem to solve.
Yeah, but now tell me one thing. How do you think are you going to build a fault-tolerant quantum computer if you cannot confirm the modularity? So that's my point. So it could be that the predictions for the fault-tolerant in 5 years will never happen. So we cannot confirm the chip of the next generation because of problems of engineering and technology. So how can I build algorithms for a machine? I have to focus on what is possible. So for me, I know now that IBM is killing themselves with their genius to make 4 chips, not 7 now. So what is Kipu doing? Already we have the algorithms for those chips, for those modular chips, but not for a fantasy chip, but for the chip that is coming. And it is already delayed. So you can imagine if I tell my investors, I'm going to build all for the next chip. I need a runway, I ask 20 millions and I employ 100 people and the chip never comes out. Where are we? Where are my investors? Where are my customers? So that's the pragmatism. So I don't think, we don't see Kipu as a pragmatic because we would like to be pragmatic. I think there is absolutely no other chance. So we as a startup, right? If you are Microsoft, you can burn $1 billion in 10 years and nobody cares, you know. No, but Kipu, as a startup, we are committed to never let walk alone the hardware providers. And whatever they manage, we are there. So for me, to say my IP will get outdated is a pride, is the correct way to go. Otherwise, if our IP would survive 5 years, this means that I am doing rubbish because the chips are changing the whole time. This means that I am creating algorithms for something that is not useful. So every IP in quantum computing that lives longer than 2 years is a totally trashy IP, in my opinion. You have to be constantly filing, submitting, creating, inventing.
I recently had Magdalena from Parity QC.
Yes.
How does that work? So how is Kipu compatible with Parity QC?
It is not, and again, I prefer not to talk about colleagues and competitors. By the way, I know them all. They are all super talented people, but each of us have a different bet, right? And Parity QC, also there is another company, this Parity QC is in Austria, in Innsbruck, also with operations in Germany, but there is another one in Germany that is also designing architectures, right? But literally they are designing fault-tolerant architectures, literally, you know. So their business model is I design architectures and the customers will pay me because my architectures are the best integration in modularity and all that. First of all, such companies have to convince a hardware company to use their architecture. So you see the multiple layer, you know. So I would develop algorithms for Parity QC in the moment where they have a huge customer, hardware provider, that said, I buy the architecture of Parity QC and I will build those chips. And when I see those chips and I know how they work, I can map. But I cannot map algorithms on hardware that is still not available. You see, not because I think it is important. If I were a researcher, you know, I can do that. I publish Nature papers, but as a startup where we have a runway every 2 years, completely stretched, and you know, always having all the problems of a startup, I am only committed to the success story. You know? So
Enrique, if we then take one step back, coming back to my question before.
Yep.
So you said, okay, on scale up, more qubits per chip, that's hard. We reach the difficulty. On forming clusters, scale out, that's also an incredibly hard problem to solve. People work on it, but it's not easy. And then on the physical, and you said on the scale up, then you need new software. You said, okay, we need to rewrite the algorithm. Is that also the case on forming the clusters that you need to rewrite the software?
Yes, but you know,
is it also the case when there has been a lot of progress in error correction ratio? If they move to newer error corrected approaches from the surface code to LDP, I don't know I don't have the acronym on top of my mind.
Yes.
But then is that the same thing that you then also need to rewrite the algorithm?
Yes. Perhaps the correct way of describing it is not that we rewrite from scratch. We make adaptations.
Okay. So how do you do that?
Yeah,
so how much can you reuse?
Just to give you an idea, within the same chip, if we went from the heavy hex 1,3D architecture to the 2D, for us it's like happiness, because literally the denser, when the architecture is more dense, the connectivity is larger, our algorithms work better. So it's not that we could just map them from the heavy hex architecture to the Nighthawk architecture like a one-to-one. We can do that, and the algorithm is just performing better. But what we do is even an additional effort to say, now that we have 2D, perhaps we can rearrange a certain part of the mapping, right? This is a question of, I think my team made the adaptation in 2 days, 3 days. It's not a big thing for us because we understand too much, right? Now, when we go for the scale out, let's say for the modularity or the clusters, then the main change, I think you will understand it very easily. Imagine that you have square chips and you connect two like that, right? So you have this layer and you have what people call the air bridges. So there is a connection between qubits that fly, because these are the integrated, and then you just put them and they are flying somehow in the connectivity. The connection between the qubits in two different chips for building the first cluster, the fidelity of the gates are less. You pass from 99.9 to 99.5 if you are lucky, right? So that's what I'm trying to say. If you now want to build an algorithm there, we have to cope with the fact that there will be some lines that will be where the fidelity of the 2-qubit gates will be reduced. And then we will map this, let us so-called same algorithm in a way that uses the less quantity of 2-qubit gates in the layer where the fidelity is less. You see, we do that not because our technology is bad, it's because we maximize the chip capacity, but this is done. I mean, AI can do it now automatically today, but we are also using AI. But we make such an engineering because if you just map and said the result is better, yes, it's better. It can be much better if you even understand the novelties of the chip. And that's what with parity will be the same. So if parity says we have this concept, it's cool. Now, when we do in the lab, they have to adapt because the technology doesn't fit to the mathematics. Then we will say, okay, the idea was there, but we have to change this connectivity and this site and this. Then we try to make the best. So that's the way we adapt. So it's not from scratch. And when we move for fault tolerant, will be the same, right? Because what many people struggle to understand is that what we do with a physical qubit will only be better with a logical qubit. Because the mathematics of the algorithms is the same. So if we are the experts in compressing algorithms with physical qubits, if you apply the same technology for compressing algorithms in logical qubits, then the logical qubits will produce better results and so on. That's it.
Okay. Can we talk about the business model and the mode?
Yep.
What is Kipu's long-term mode? Is it proprietary data, proprietary algorithms, hardware partnerships, the customer visibility, roadmap, customer workflows, data, benchmarking infrastructure, or talent, or other things?
That's very, very good question, because this is about a topic that you may think that I was talking about another company. But so you asked me correctly to go deep into the technology, into the digital, into the analog, and all that, right? But literally, what Kipu has strongly shifted this year is from that to an upper layer that we called quantum-centric intelligence. So quantum-centric intelligence is the adaptation of our company to another reality check that is not quantum computing or chips. It is AI. AI is a monster. So I am in total awe and admiration for the AI. I truly believe that AGI is in the next in the next corner. So I truly believe that AI is here to stay. So I created the concept of quantum-centric intelligence, where not a single user, customer, not a single engineer or scientist will ever have to ask me for Python code, algorithm, fidelities, error mitigation. So I believe, and Kipu believes, that the times of that language is gone forever. And we have to move to what I call quantum-centric intelligence, where the users and the customers in natural language say, my company is telecommunications. I have 2,100 nodes, and I need to an optimization because each time there is a problem with electricity here, this set of customers loses the accessibility, and I need to make a rerouting, and speaks. And if you go to our website, you find that already. It's called Tinkuk, is a Quechua name. It's the name of our first agent. And the agent in natural language will tell you, what? Come back in 20 years. No hope for your problem. Or, you know what? Higher order binary optimization. Your problem enters into this category. We can make a workflow combining Cplex, that is classical solver, with the digitized quantum quantum optimizer. IBM is not perhaps suitable. We should do it in D-Wave, or we should, the AI makes the model of the solution. And next week, we will announce the second agent called Pakari, who is the executor. And the customer can say, okay, and you tell me that you will solve my problem faster, more accurate, energy, or pricing, or cheaper. Then puts the credit card, and the second agent that comes next week executes the composition of the work. I don't know if you get my point. The composition probably never existed before, even in a human mind. So the AI invents the service, you see, and delivers to the customer. So I believe that the way Kipu, the only possibility that a quantum computing company, and Kipu in particular, can exist longer and successful is by combining the maximal power of quantum computing with AI. That's what we call quantum-centric intelligence. So the AI, I don't think that nobody in the next years will speak to me about fidelities, noise, error mitigation, logical qubits, physical qubits. The people will speak natural language. So that's what I was so tough with myself saying. I was criticized for not being hardware agnostic. I am telling now our investors and our customers, yes, we were never hardware agnostic, but now we are language agnostic. Mm-hmm. You can talk to my AI in any language, and it will solve your quantum computing problem. That's more or less what I think is the future of our field. But not only of quantum, of everything,
If AI is the game in town, how does Kipu try to be the best in AI?
Essentially, exactly, because we are, I didn't say it in that manner, but now I can say it after these long explanations. We do everything that can be cast in the language of quantum-enhanced machine learning, quantum-enhanced AI. So when I spoke about my quantum reasoning LLM, we have a composition of quantum and classical workflows in sequence, classical, quantum, and there is a drawer that is empty. We take it out and we put ChatGPT, we put DeepSeek, we put Llama. We close the drawer and we run it. The result saves energy, reduces hallucinations, increase accuracy, and blah, blah, blah. So literally, we have hybrid workflows that where you put me a commercial LLM and we make it better because there is a component of the workflow that uses a quantum computer. In this case, a quantum reasoning engine. You see, so that's why in the past we said quantum versus AI, quantum versus classical. I think this was...
Enrique, I fully understand the hybrid approach. But what I'm trying to understand here is what is unique about Kipu on the combination with hybrid? So
we enhance it.
What are you doing better than your competition?
That's my point. We declined some time ago to compete. We just pick the best of if you give me the best AI, I make a quantum enhancement. So I get it better because of the quantum, but I don't compete. So quantum is not beating AI, it's enhancing.
No. That part I understand. Yeah. But what I try to understand is how do you organize and optimize for this? So this is your worldview.
For example,
in quantum.
In the case of quantum reasoning,
and as a CEO, what do you need? How do you prepare Kipu Quantum for the next 3 or 5 years that you are the best player in this game?
I mean, I cannot answer that question without invoking some geopolitical issues. Oh. Yeah, because essentially I would like to speak about GPU success. I would like to speak about supply chain. I would like to integrate to have one day sooner than later an agreement with Anthropic, because we use Anthropic tools, to have a common go-to-market. I could speak about all things, but that in Europe we cannot use now the last successful technologies of Anthropic. So we perhaps have to work with only European AI. So it's a very, very complicated landscape that we are facing, and Kipu is preparing ourselves. I just come from 2 weeks in US. I consider seriously moving completely to US if this continues like that. So Kipu needs to be only talking to the most advanced AI and to the most advanced quantum computer providers. We cannot, the model of Kipu is make quantum useful now. So we cannot say, okay, we support Germany or France with a little quantum computer because I cannot. So our business model and technology model is such that we are always partnering with the number 1, 2, and 3 in hardware and number 1, 2, and 3 in AI. And if that needs that I move to US to have all the resources, I will do that. But that's a personal issue and a responsibility issue. It doesn't sound very fantastic for Europe, right? Or for Germany.
And Enrique, what is your plan to increase your power in the value chain? Is it better algorithms? Is it broader backend support? Is it stronger independent benchmarks? Is it fewer reduced humans services per deployment?
We cannot aspire to more because we have all that. Our partners in hardware, in the quantum computer hardware, we have the direct partnership with the best quantum computers in the world. There is nobody that making them, and it looks like it will stay like that. On the CPU GPU access, we are in the NVIDIA program. We have a platform. We have the most advanced transfer in Germany. So really, we are pretty much spoiled. That's what I don't accept less than leading worldwide. We have everything we need. What I was saying is more the negative thing. It could well be that all that great things we have, we may lose because of geopolitics. For example, if IBM says, "Oh, the next chip you will not have it. You will only have it when comes the third chip. I will give you access to the first chip or to the second, but not to the last one." So that's a really dramatic situation for us as a company, right? So yeah, in this moment, we have everything we need. Now, the next scale up for Kipu is Series A. And if my announcement that we will go in production in these next 2-3 months with 2 top customers, and we succeed and comes 10 more customers saying, I also want the same, we don't have the capacity to deliver. So we need funding. But we don't need, in this moment, neither hardware, quantum computers, neither CPUs or GPUs, nor algorithms. We don't need anything. We just need time and trust to scale up the business. I'm not a guy that goes around the world asking for more. But let's say the fundraising has to be justified by strong demand of customers. Strong.
Let's talk about customer demand and customer adoption. Yeah. Can you walk us through the customer momentum? Which clients do you have, and how is the pipeline? How is it filling?
Yeah. So in this moment, so let's say the usual customer of any quantum computing software company has historically been the innovation departments of corporates. Okay, public funding and innovation departments. Kipu has allergy to both. And the explanation is very simple. Public funding created the concept of grant-entrepreneur. And I know too many quantum computing companies that are living from public funding, which creates a laziness in the creativity and in the delivery.
So, is it also fair to say that it makes you very slow?
It makes me slow, makes me feel comfortable. It's a too happy situation for delivering nothing, As I said, I'm not going to mention competitors for respect because I have respect and admiration for their work. But I know companies in other countries, that are getting 5, 10 millions, 15 millions requests from governments to build the fault-tolerant quantum algorithms for the future. And if Germany would offer me that, I'm sure I would accept. But is that a way to make a technology? So a company receiving 10, 15, this means you have a runway of 2 years for doing things that do not exist. So I don't like that. Second, when you receive public funding, you have to so for me, every euro of public funding is loss of money for people because the money arrives at 50%, at 70%, so I have to put money. Of course, it looks like I am getting some level of revenue, but I consider it, we have that level, but we start to be allergic. So we don't want that this is a justification why we are not so advanced. This is one thing. And the second thing concerning the innovation departments is that this is a fake and false business model. Innovation, we have learned that innovation departments come to you because they are paid to be scouting new technologies. So literally you get your POC, 100K, 200K, $500,000, depending on your country, or even 1 million in US, and then you are kicked out. There are companies, as I said, I don't mention names, but you can check easily in US that have disappeared. Now they are coming back even because, and they reach $20 million of revenue per year. How can it be that you go? And the reason is because your customers are fake. Are customers that pay you and then kick you out. The Kipu is obsessed with attracting customers, where we tell them, I only accept to make a POC if I can show you that my quantum computing solutions can add value with the chips of today, or at most the next generation that is coming. If a customer requests something where we cannot show that, we don't work. We prefer to disappear. That's a very tough benchmark for us.
Fair enough. So you don't want to focus on research grants,
No.
Government grants, and also the proof of concept. You really want to have real life use cases that
Absolutely.
have impact.
Absolutely.
And that prove that you can do something meaningful with quantum and the hybrid approach.
Yes,
So
because we are
based on
not
that-
here to play games. We are not here. At least I didn't create Kipu to
No.
become billionaire in an easy
what-
manner. But I
Enrique,
want to create a revolution. Yeah.
what data points do you have that you can show that the customer momentum, how did the customer momentum changed the last 3 years? So if you go back 3 years and now it's now, what is the change in the tone when you speak to customers?
Oh, very good. When customers, we have seen, again, without mentioning names, we have seen innovation departments of top corporates asking us for quantum computing, that they have informed us that the second and the third round of renovation of the contract cannot continue because they themselves are being cut in the budget for quantum. So that's what we observe. So our survival attitude is not to say, okay, now I give me 10K and I solve something. No. Our reality check is, let us go for the real customers. And what we are doing now is, when a customer approach or we approach the customer, we tell them that use case that you are requesting is non-viable for the technology of quantum computing today or in the next 3 years. And you can ask another competitor for that. We cannot. Yeah, but that's what we need. That's what, okay, we'll look for something else. So we are very selective in what brings us value. Also, public funding we accept. For example, in which condition? When the public funding allow us to explore a use case that was not known to us. We say, oh, we never tried that application, and I think we may fit. Okay, we absorb public funding, that taking the risk. Or a customer that says, I know that this cannot be solved with quantum computers today, but what about making an assessment for the next chip? So we become super selective. Of course, by doing that, we can find ourselves with empty hands, right? Fortunately, every customer that works with us receive the pure truth about the delivery and what we are truly offering. And let me quote 2 customers, because you will know very soon in 2 PRs. One of the largest American banks have tested our quantum computing solutions for customer chain reduction. That is a bottleneck in classical machine learning, and they told us, if you increase 1% my solution, nobody in 10 years has been able to increase 1%. This is a super bottleneck. We save hundreds of millions of dollars. We improve 2%, 3%, 4%. Then they said, delivery of the services, sub-second level, impossible with quantum computers online. We invented a surrogate principle to represent the whole quantum workflow. And now we are working with this large bank to go in production in 2-3 months. So in 2-3 months, we might be announcing the first moment in history where a quantum computing solution is used in production by one of the largest banks on earth. So we expect that if we are focused on that level of challenge, this will propagate immediately. So we are expecting the diversification of the market after this announcement. So that was for customer churn reduction. We have another company that I will not quote the name now, but you will see in the next weeks, There is an energy company providing us with real drone images of leaking of gas in pipelines, where we have to predict the replaceability rate of the pipelines for not having explosions. We are solving this better than classical. And we are also paid by this company to enter in production with them together in the next month. So if we show at least 2 examples how companies can integrate in production our quantum computing solutions, I cannot doubt that the market will react as saying, what about me? I am also a bank. I am also a drone imaging. I'm also satellite imaging. So we are playing the game of extremely focusing on important use cases and customers that will immediately create an amplification of the market. If we go for the fault tolerant of the future or for solving things that do not have hardware, I'm fine. If others are happy, I cannot be happy with it.
So maybe to summarize is, at the moment you have 2 use cases which you expect to announce within 3 or 4 months.
Yeah.
And when they come, you think they show clear benefits,
Yeah.
and that you expect is because you have those use cases of real quantum benefits, that it will trigger additional demand.
Yes, absolutely. Because these are not little customers. You will know the names and you will say, really? And these customers immediately trigger the famous domino effect, right?
Yeah.
To say the competitor will say, what? You are saving 300 millions because I also want it. I also want it. And that's the way we are.
Enrique, how much capacity do you have? How easy is it to scale? Because
that's a problem. As I said, because we are doing, let's say, we are very, very compact team, very integrated team, super talent, super efficient and all that. But we cannot, in fact, I had a meeting this morning. I was telling my team, imagine that we announce this with this American bank and we have 5 other American banks coming. Can we deliver? The answer is no. That's why we go fundraising. But as I said, the fundraising is to show the investors that there is a customer attraction for something valuable. That's what I call really attracting investors. I cannot anymore attract investors by saying, in the future, I will solve a problem. My character doesn't fit to that,
Yeah, what is the cleanest evidence that Kipu has achieved genuine quantum advantage rather than clever quantum?
This is a very, very heavy debate in the community, right? And I would like to say it myself, but I will quote Jay Gambetta, that for me is probably the single most knowledgeable person that matches claims, academia, and industry, right? Director of IBM Research. He was giving a talk in IEEE Quantum Week last year, and somebody asked him the same, because he was saying, we are living the times of quantum utility. We are possibly entering in the area of quantum advantage, and later the real stuff would be the quantum usefulness. Then I told Jay, look, I prefer to call it industrial quantum usefulness, because many people will tell you it is useful because I publish a paper. No, it has to be industrial quantum usefulness, like a business model. And there was a question of the audience that asked him, challenged him, yeah, but how you define correctly quantum advantage? Then I think spontaneously he said, honestly, I don't care. What I care is if I do one of our startups, hopefully Kipu, right, makes a quantum computing solution, offers to a customer, the customer tests it and said how much it costs, it saves money, it solves problems, it is faster, it is more accurate, and the customer pays you annually, and you create ARR, right? So for me, Kipu is obsessed now with that point. So we pass about the debate of quantum advantage, and we are going to show customers using quantum computing solutions where they say publicly, this solves my problem, it is cheaper, faster, more accurate, saves energy, and I'm paying happily. So that's my definition of quantum advantage. And in a smart or elegant joke to some of our investors, I told them, what is quantum advantage? That one day I arrived to my office in Berlin, and I find a queue of 100 people that I never met. And each of them tells me, you are the CEO of Kipu. I have the pockets full of money, and I want to pay you for this, what you announced yesterday in LinkedIn as a new product. So that's quantum advantage.
Enrique, you mentioned, you want to do a Series A, or you're going to do a Series A, not want, yes. You're going to do it.
Yes.
And then how much money are you raising?
I mean,
What is the plan?
it will be at 20 plus millions at a valuation of 100 millions at this stage of growth.
And for the audience, what will you do with the money, and how will that enable you to create a positive flywheel?
I will only fundraise and absorb the money if my company is desperately needing it for delivering our quantum solutions to a queue of customers waiting in the door. I don't think that Kipu fits to ask for money just to wait for future markets. So I want to make it happen, and I want to make it happen now. So that's what I will do with the money. The money will be requested with evidence that there is a huge traction of customers wanting our solutions and that we cannot deliver. That's the way I see my Series A.
Yes, and the money, what do you spend it on? Is it on only?
That's a very good point, because
talent. Or?
One of our investors, I don't know if he was serious enough. We absorbed some money, some millions in the last months internally. And one of our investors, okay, I will put this money if you convince me that AI tools will be replacing employees. I thought it was a joke, because this is a debate in the society. Are we creating technology that makes humans useless, And yes, I guarantee that the money will go to hire some humans, but we are moving to quantum-centric intelligence. So we will become like quantum cyborgs. So we will have AI employees, we will have human employees, we will have quantum employees, we will have AI employees. So we will be a hybrid team, So it's impossible, as I said, as a business model to say, oh, Kipu will only hire humans, we'll reject AI. We cannot. You can state it as a wish, but the reality is that the level of efficiency that investors and companies will have in the next years will be bound to how AI is complementing humans. And I am ready to use this money for an integrated CPU, GPU, QPU, human you. That's the only way I see it coming, and to be very transparent. Right? So we will not be saying we need 20 people. If we need 20 people, the question is, can it be 12 people? And perhaps 8, the money for 8 employees can be mapped into GPU access or AI tools, That's a fact.
Okay. On the personal drive, where do you get energy from, Enrique?
I love that question, yes. I think I said it at the very beginning. This could be a very cool rounding of who is Kike, right? I feel me a victim of my genetics and brain, as I said. Sometimes I feel that I am just obeying as I call it, my quantum destiny. I wake up, and when I know how hard it is to make quantum computing useful for industry and for applications and for society, it's a very instinctive attitude in my mind that makes me happy. And if you say, why you make happy? The only answer I can give you is that difficult problems that are meaningful for the history of humankind require smart solutions. And I think that I was blessed in my life by my history, my family, my teachers, my mentors, my investors. I was blessed to have the chance to express that creativity for something useful. So that's where I take my energy. In part is a personal ambition, and in other good part is thanking the opportunity that I have. I feel me blessed by having trust of investors, of customers, of our team, of our people. So it's a combination of personal ambition with responsibility, human responsibility. Yeah.
Enrique, who are your main competitors?
I don't know any.
Is nobody? Your approach seems very pragmatic.
It's not the approach.
And it sounds also a logical approach. So
exactly,
why is nobody?
That's the point.
Nobody doing that.
It's a very difficult question. In fact, I think one investor 3 years ago just abandoned us because they asked me something like that and never asked me that question, and then I spontaneously said, no, the question was, why Google or IBM disagree with you, and why they are better paid, they have more talent, they have coming from all the elite universities in the world. Why do you think you are right and they are wrong? So that was the question. And my very, very spontaneous answer was, because we are smarter, And of course, the guy took it like, how can you be smarter? Your salaries are less. You are not Google. You are not. I think there is a value in being the rebel, the rebel kid in the quarter, And I think I started Kipu not when I was a young, unexperienced researcher, but after completing a super successful career. I am the most cited CEO in quantum computing in the world. That's not something that I do it only for arrogance, but that's the truth. And I just try to transfer that power and that know-how to something that is not hype. So I do believe that we are rebels. Also, my investor sometimes tells me, Kike, you don't hire anyone that was Harvard boy or, Stanford guy or Max Planck people. And I didn't realize, but that's true. I hire people that I perceive that have the same drive like me. Like they say, I have an opportunity to poke history of technology. And of course, they are talented people, but they are people that have a lot of hunger, like we are people that are hunger for glory, for history being made. And that's perhaps what keeps us energetic.
Enrique, why is Kipu able to innovate the fastest? And can you walk us through the positive flywheel?
I don't understand very well that question.
No, so a lot of things are happening, and at the moment you say we have no competition.
Yeah.
But in order to stay ahead in the future from competition, it's important that you innovate the fastest.
Yes, that's I said it before. I repeat it in this context. No, again, it sounds very arrogant, but that's the truth. So every time we make an announcement via a scientific paper, via a blog, via a service, via a product, every time, and the world sees, okay, Kipu is there. If you speak inside the company, that's already boring. That's already past. That's not interesting. So every time the world knows about an achievement of Kipu, internally we are two steps ahead. So we are very, how to say, I coined many mantras in my life when I was leading many teams, but one of them was celebrations for success, 5 minutes. We don't enjoy celebrate. I don't celebrate. It's boring for me. The celebration is, so when we achieve something, we are looking for the next hard cookie. We are not a people that are falling in. So for us, our status quo and our modus operandi is, where is the next challenge? Where is the next? That's the mentality in Kipu. So we are not people celebrating a success. When you see a success of Kipu, inside we are somewhere else. And that's the way that's my character, and my team follows that. They are used to it. Okay. We are not committed to, we work, we have a success and we stay there. No. It's success, 5 minutes, then back to the next challenge, the next challenge. That's
Enrique, I have one last question to wrap it up. If we meet again in 2030, wow, what would success look like for Kipu Quantum?
That you tell me, Enrique, why are you doing something else? And my answer would be, because we made quantum computers useful now. It is just the world is taking it, So if my mind, if in 5 years my mind is focused on AGI or quantum AGI or creating quantum computers that think better than humans, this would be a sign of success, because I'm not a quitter. So I will not stop until quantum computers are useful in the next years. So I hope that in 5 years, my creativity and drive is somewhere else, because this would mean that I achieve my goal of Kipu. You know, yeah.
And for investors, why would that be the best outcome? If you achieve that outcome, what would it mean for investors that put the capital in?
I would like, my dream with investors is that in 5 years they tell me, hey, Enrique, that's it. You made it. You don't have another brilliant idea. I mean, I have a lot of money to give you, but create me something else, you know. So for me, these are cycles of creativity and achievement, right? And I would like that my investors tell me, now it is a question of creating the multi-billion-dollar company. You are good at inventing and accepting it. Is that a challenge for you, or we have money for new technological ideas? And I am truly eager to finish the task of Kipu becoming the first company making quantum computers useful for industry, to move to the next step, that is enhancing human intelligence via quantum computing at the level of human intelligence, not just calculating something better. Right? So I'm very driven. That's what I mean. AI for me is core to Kipu today. But if Kipu consolidates like a top company for industry, I think the next step is to go for the human brain.
Okay, maybe to wrap it up in one sentence, why should investors put the capital at Kipu Quantum?
Today, because of what we achieved. 3 years ago, because of our promises. But today is because we can prove that we can add value to customers via quantum computing solutions designed by Kipu. We are at the point of proving things. I don't think that the Series A will be based on promises. The promises is of scaling up, but the technology, we can prove that it is successful.